saya Syahira binti Abdullah.
My name is Muhammad Syafiq bin Abu Hassan.
Hi, Assalamualaikum. My name is Siti Nonanda Salma binti Salahuddin.
Assalamualaikum. My name is Umaira Iman binti Hairi.
Assalamualaikum warahmatullahi wabarakatuh and good evening. So today I will demonstrate the process that we have been choose, which is batch leaching process. Okay, so what is batch leaching process? Batch leaching process is known as solid liquid extraction. Okay, so now what is solid liquid extraction? So solid liquid extraction is where the solute diffuse from the solid to the solvent liquid when the solid and the liquid is contacting.
Now I will further explain about the process of leaching. In this experiment, we use oat as our solid to extract oatmeal by using water as solvent. So, how does this process occur? This is because of leaching process. Then, how the leaching process happen between solid and liquid phase in this experiment? First, the water solvent is transferred from the bulk solution to the surface of the oat. Next, the water solvent diffuses into the oat, which we call it as intraparticle diffusion. After that, oatmeal dissolves from the oat into water solvent. Can you imagine how it happens? Let me continue on the explanation of the process. After the oatmeal dissolves into the water solvent, it then diffuses through the mixture to the surface of the solid. Finally, the oatmeal is transferred to the bulk solution. I am sure that you can imagine how the leaching process occurs between oatmeal and water.
So for this demonstration, the material that will be used is oat, solvent water, and blender for blend the oat to get the crushed oat, and sieve the slurry with the oat milk, and weighing scale 2 cup weighing for the water and 1 for weight oats. Okay, for the slurry we will put inside this bowl. So this is 3 bowl for 3 rounds. So now we will do our first demonstration by using 50 grams of oats and 100 grams of water. So let's start. Okay, first thing first, we need to wait for 50 grams of oats. Then we put it in blender to ensure it is crushed before we extract the oatmeal from the crushed oat. And then we wait for the water there and 100 grams of water. So before we put water, we need to ensure that this oat is crushed a little bit before it is extracted by water. Put 100 grams of water in blender. 30 seconds at least to ensure that the water and the solid were contacted to extract the oatmeal. After that, we sieve our oats and the water to extract the oats and the milk. So now we need to weigh our glass cup and milk, and then our sieve and our product. So that's it for the first round. We repeat the experiment with 200 grams of water and 300 grams of water.
We will be explaining the problem statement part. The first question is, how do you prepare the material for this process to achieve high extraction rate? For this experiment, we use a constant mass of oat and 3 different masses of water. The first method is using a higher solvent to the liquid ratio, where we use 100 gram, 200 gram and 300 gram of water to a constant 50 gram of oat. Second method, use normal temperature solvent to prevent undesired extracted product concentration, as oat milk will become slimy at higher temperature. Moving on to the second problem statement, how do you choose the best extracting solvent for this process, and what are the criteria that need to be considered? The extracting solvent chosen in this experiment is water, and there are 5 criteria to be considered. The first one, in terms of cost, using water is cost effective and cheap. Second, resource. There are abundance of water resource such as surface water and groundwater. Third, solubility on target compound. The compound to be extracted is soluble in the extracting solvent. In this experiment, oat milk is soluble in water. Fourth, solubility on impurities. Impurities should not be soluble in the extracting solvent. For this experiment, oat grain is not soluble in water. Fifth, in terms of toxicity and safety properties, water is non-toxic and also non-flammable.
These are the results from the previous experiment, and these are the certified data of the results. This is our block flow diagram for our process. As you can see, the feed slurry donated as L0 is our solid oat that contains 10 weightage % of oat milk. And another yielded is our solvent feed, which is water as our solvent that we use for this experiment. To calculate extraction rate V1, we use overall balance, component balance, and also solid balance. And from these equations, A is labeled as our desired product, which is oat milk, and B is our solid oat, and C is our solvent, which is water. To find V1, we need to find the coordinates for L0, V2, and also M. At L0, the inlet of our process, we assume the mass fraction of oat milk is 0.1, and the mass fraction for solid oat is 0.9. And then we calculate the mass of each component, A, B, C, and from these calculated values, we calculate the solid concentration in feed slurry Y0 and also the solid concentration in the feed slurry N0. At solvent feed, which is at V2, we also calculate the mass of each component A, B, C, and then we use these values to calculate solid concentration in overflow XA2 and also solid concentration in overflow N2. For M coordinates, we need to find the value for M by using the total solution balance, and we need to find XAM by using component air balance, and we need to identify the NM by using the solid balance. Next, we calculate the slurry at the underflow, which is N1, to be plotted on the graph 2. N1 can be calculated by using overall balance and solid balance. Then, these coordinates for L0, V2 and M are identified, so these values are plotted on the graph NA versus YAXA. After the graph is plotted, a straight line is made between L0 and V2. The solid concentration at L1 and V1 can be determined by plotting a straight line parallel to y-axis to M coordinate. From this graph, the solid concentration of oat milk can be determined. Next, the extraction rate is calculated using the overall balance and also the solid balance. So, all of these steps are repeated to determine the extraction rate V1 by using different mass of solvent V2, which is at 200 gram and also 300 gram. By changing V2, we can understand how this process can be done to achieve high extraction rate. So, here is our finalized data for our calculated V1 for each one. This is the process flow diagram to produce oat milk in industry. Firstly, pure oat is pre-treatment by destruction to reduce the level of anti-nutrients in the oat. Next, the oat will go through extraction process by leaching to extract milk from the solid oat into the solvent. The oat then formulated and fermented to increase its protein content of the oat milk. Lastly, the oat milk will ready for the packaging process. However, to calculate the extraction rate, we focus on the filtration unit during the extraction process.
There are several recommendations to improve the selected process. During our running, we need to ensure that all the data reading are taken correctly. As we use digital weighing scale, we need to ensure that collected weight is not influenced by the air surrounding, as the digital weighing scale is an open weighing scale. Furthermore, in order to get more purity solution, we need to use a fabric with a small porous to gain less solid in the solution. Last but not least, to get a good solution, avoid from soaking your oat in the water solvent before blend it to prevent getting slimy oatmeal. Now, to conclude this experiment, the objective of this experiment is able to achieve. It can be seen that extraction rate from this experiment can be increased as the inlet rate increases. Besides, the mass fraction of oatmeal can also increase by increasing the mass of oat at inlet. Last but not least, from the experiment, it illustrates that working principle of leaching process in industry, and we are able to apply the leaching process in our daily life to reduce cost in buying oatmeal. That's all from us. Thank you.